Welcome back to the Scotti-BYTE channel, and this is Scott. So today I want to discuss what makes a good self-hosting server. And it's easy to buy Dell PowerEdge or HP ProLiant servers cheap. And in fact, out on eBay, you can regularly find several of these servers for the $250 to $350 range. And sometimes they even include memory, but often they do not include hard drives, which can be pretty expensive because many of these servers require SAS hard drives. So then, aren't Raspberry Pis actually cheaper? So a Raspberry Pi is pretty compelling because it's a very simple single board computer. It's small and it's compact and it doesn't use much memory. And it actually, on the surface, looks like it has some pretty good specs. And you can see here that the Raspberry Pi 5 has a 2.4 gigahertz quad-core processor, which is 64-bit, and that processor is an ARM Cortex-A76. Also, looking down the specs here, you can see that it has dual 4K 60 frame per second HDMI output, and it has a 4K HEVC, which means high definition decoder in hardware. And then it also has dual band Wi-Fi, although it's only 802.11ac, which is not Wi-Fi 6 or Wi-Fi 6E or Wi-Fi 7. As we look down on the list here, we've got USB 2 and USB 3. And probably one of the most disappointing facts is that we only have a PCI Express 2.0 single lane interface. And we have to connect our storage in some way, and that's usually USB 3. So the Raspberry Pi 5 in 8 gigabytes, which is the larger configuration, is $80. And we still have to buy a case, a power supply, and some type of storage. So the question is, how many virtual machines can we run on that if we make that a home lab server? And I argue that you can probably run 2 virtual machines or 3, and they have to be fairly small. Certainly, if you chose to use the new ARM distribution of Windows 11, you probably can't even offer it as a virtual machine on this, so that you would probably dedicate this machine to that one operating system. So then the question is, how many containers? Well, if we're running Incus or LXD, chances are we can probably run comfortably 4 containers on this perhaps. And beyond that, I really wouldn't trust it because we would be running up against a bottleneck in regards to our memory. So what about fast storage? And that's an issue because there really isn't any way to integrate fast storage onto a Raspberry Pi unless we're doing something like maybe mounting iSCSI over its gigabit Ethernet port. And I don't know that you can actually boot from that. So then, are desktops a better choice? Well, so obviously a desktop takes up far more space, and desktop systems certainly are a lot cheaper than this Dell XPS desktop I'm showing here, which is basically a $1,500 unit. But desktops are pretty intriguing because they can offer some pretty large processors. In this case, we've got a Core i7, not really a barn burner, but one of the better choices. And certainly you can put more memory in them, typically 32 gigabytes, although now with DDR5, arguably, I think you can probably go to dual 48 gig SIMs and probably take it all the way up to 96 gigabytes. So we'll talk about memory later. And then they have an NVMe slot in here, which is a good thing. Most new desktops are going to have that, and that really matters. And just note here that it has a 460 watt power supply. So then I really like mini PCs, and I like to recommend the use of mini PCs. And part of the reason for that is because the power consumption is usually around the 12 to 25 watt range. And when that system is at load, it typically will consume no more than about 60 watts. And power supplies are often only 12 to 20 watts or 12 to 20 volts, I should say, for a mini PC. So mini PCs are very efficient. And they also have very low heat generation. So unless you live in a very cold part of the world, here in Texas, I really don't want any more heat. We've got plenty of that already. And so servers that don't generate a lot of heat are definitely going to be my prime choice. So many PCs are only in the $240 to $400 range, and they usually have processors with 4 to 16 cores. Now, that being said, I know that you can easily configure a mini PC over $1,000, but we're just talking about averages in general here. So newer mini PCs will have DDR5 memory, and they give you the option to have dual 48 gigabyte SIMs, and so you can push their configurations up to 96 gigabytes, which is really pretty attractive when you're doing a lot of virtualization because more memory is better. And many PCs even offer dual 2280 form factor NVMe drives, which are the full-sized NVMe drives, and SATA ports as well. So some mini PCs now are also offering the Oculink 2 ports, Oculink version 2 that is, and they are optical copper link alternatives to Thunderbolt. I always thought that was interesting, the name Oculink being optical copper link. The funny part about that is because Oculink interfaces have never been optical. The conception of them to begin with was that they would be optical. But the neat part about them is that an Oculink port basically takes your PCI Express bus inside of a mini PC, and it makes it external where you can connect a Oculink dock outside the machine. And what that does is it expands the PCI Express bus outside and will allow up to a PCI Express 4.0 times 8 slot, supporting transfer rates of up to 16 gigabytes per second. So some mini PCs also offer USB 4, and you really got to watch these USB specs where they say USB 3 or USB 3.1 or 3.1 Gen 2 or 3.2 or USB 4, because you really have to read the specs. But USB 4 is typically either 20 or 40 gigabytes per second. Yes, I know the spec now technically says all the way to 80 gigabytes per second, but I don't know any machine currently supporting that. And then the last thing here, and I think it's a really important thing, is that mini PCs are small. They don't take up a lot of space. So what exactly does your home lab or any home lab need? Well, home labs need virtualization. And traditional virtualization means virtual machines. So probably for about 20 years now, we've had virtual machines running out in the wild, so to speak. A lot of companies use virtualization. Why? Because you can take one piece of hardware and make it look like lots of different computers. So I cover Incus and LXD containers on the channel, and they virtualize only the operating system and they don't virtualize the hardware, whereas traditional virtual machines also have to virtualize the hardware, so that makes them relatively heavyweight, whereas Incus containers are and LXD containers are very lightweight. So Incus and LXD containers share the host kernel, and therefore they're much more efficient than VMs, as I had alluded to. So Incus and LXD provide a CLI and API front end to this standard Linux containers, otherwise known as LXC. And LXD is developed and supported by Canonical, the makers of Ubuntu. And Incus is an open source fork of LXD that started in early 2024, so it's only been around about a year, and I prefer it mainly because it's going to be adding more features and functions, whereas LXD, supported by Canonical, is going to focus more on trying to interface with various Canonical projects. So Incus supports Incus VMs, which are essentially QEMU VMs. So those are full-fledged VMs that have to do hardware virtualization like any other VM. They also support Incus containers, which is really what I'm talking about. And then most recently, in the last couple of months, they're supporting something called the Open Container Initiative, or OCI, otherwise known as Docker containers. So really, with Incus, we have three types of virtualization. So what do I look for in a mini PC? Well, I recommend a minimum of 16 gigabytes of memory. So that kind of rules out our Pis. And 16 gigabytes of memory seems to be a good starting point. And generally with 16 gigabytes of memory, even with some more aggressive Incus containers, you can probably have 10 containers or so. So I say look for a mini PC with DDR5 because expandability is really important. Any DDR4 based mini PC will support up to 64 gigs of memory, and the reason for that is because right now mini PCs typically accept laptop memory, and they generally have only 2 SIM slots, so 2 times 32 gigabytes. Whereas with the DDR5 based mini PCs, they also have dual slots, but there are 48 gigabyte SIMs available, so that's what will allow you to go to the 96 gigabytes. And then fast NVMe storage, I think, is really important because when you have a lot of virtual containers that are running out there and they're vying for CPU time, CPU is not the bottleneck. The bottleneck is accessing the storage and making sure the storage is fast. So that's why I recommend NVMe. A lot of your mini PCs come with NVMe storage, and a lot of them now are coming with a 1 terabyte NVMe rather than 512 or 500 gigabyte NVMe's, which were much more common even a year ago. But I want you to consider a 2 terabyte NVMe. So in terms of cost, a 1 terabyte NVMe US price is about $50 or so. A 2 terabyte now, as of this recording, would be probably about $130 maybe. The 4 terabytes are going to run more around the $250 range. And of course, they go all the way to 8 terabytes, which are completely unaffordable. But more storage is better. One of the things you'll find out is that if you have containers that have large storage requirements, they're going to use that storage space. I also recommend remote mounting things. So if you have a NAS out there, consider using something like NFS to mount storage back to your Incus server and then have containers use that storage, which is a technique I've frequently shown on the channel and explained how that's done. So more cores are better, and multiple threaded cores are even better than that. So my really low-end server that I use, in fact, I've got 2 of them here, are little minis forum devices, and they have 4 cores and 2 threads per core. So basically, they look like 8 pseudo cores. And more cores are typically better because they run faster applications better. But more than cores, faster storage, and more memory. And more memory is definitely the number one requirement because memory goes fast. So most new mini PCs also offer a 2.5 gigabit NIC. I would encourage you not to look at any mini PC that only offers a 1 gig NIC, although those are becoming more rare. If you have a 2.5 gigabit NIC, note that you're also going to require in your infrastructure a switch that supports a 2.5 gigabit interface. Because if you plug your 2.5 gigabit mini PC NIC into a 1 gig switch, you're only going to get 1 gig. So then I also say that USB 4 and Oculink provide additional expansion. A lot of people have said that traditionally mini PCs don't provide a great deal of expansion, but I think that when you add interfaces like Oculink to make your PCI Express external, then you're going to provide that additional expansion. And fast USB interfaces like USB 4 give you options. And then built-in video, well, most mini PCs, they're kind of single board computers, and they have usually an AGPU, so they basically support internally an integrated video. That's not really important. When you're originally setting it up to be a server, you'll use that video, but after that point in time, you'll typically disconnect the keyboard, the mouse, and the monitor, and then from then on, you'll only SSH to it through its Ethernet port, so really the video doesn't matter. And then on the higher end, perhaps an Oculink interface to an NVIDIA video card with lots of CUDA or Tensor cores. And so if you don't know what CUDA cores and Tensor cores are, those are the two types of massively parallel cores that we find in the high-end graphics cards with multiple graphics processors. And these can be used either for applications that require transcoding for large videos, or the up-and-coming AI applications also benefit from the massively parallel cores that you find on these GPUs. And while we're talking about Oculink, one of the other things I'm hoping to see is that today Oculink docks are primarily a single slot in those docks, and they provide a PCI Express 16 slot, but it's only enabled for PCI Express 8. That being said, they do support up to PCI Express version 4, which is really good. I'd like to see a dock that actually supports multiple slots. And the reason for that is because I'd like to be able to put something like a network card in addition to a video card, and the network card might have an SFP plus connector on it, so I can connect my mini PC via 10 gigabit. So what can a mini PC do with Incus? Well, I have a low-end Minisforum UM350, which I spoke about earlier, and it presently hosts 32 containers and 3 Incus virtual machines. And so this is a display from Lex Console, and Lex Console is a GUI front end to manage an Incus server, and I've presented multiple videos on it on the channel before, but you can see here that I'm actually running 32 containers. I'm running 3 virtual machines, and by the way, those virtual machines, one of them is an Ubuntu desktop, one of them is a Home Assistant virtual machine, and believe it or not, the last one is a Windows 11 virtual machine that is allocated 8 gigabytes of memory. And so as we look down on the list here, we'll see that my Incus server is at the latest version as of this presentation, which is version 6.5 in September of 2024. And it says that it has an x86-64 kernel, and that is because it has a Ryzen processor in it. And then down here you'll notice the driver. Well, it uses the Linux container driver of 6.0.2, and it uses the QEMU driver for the Incus virtual machines of 9.0.2. And this particular machine has 64 gigabytes of memory, as I mentioned earlier. I know it listed here as 66. I'm not sure why that is. I think it might be a firmware issue because clearly I have 2 sticks of 32 gigabytes in there. I do not have an ability to expand it because this is DDR4 memory in this particular machine. But this machine has 4 cores and it has 2 threads per core. So you see the CPU count, the pseudo count is really 8 cores. And that really comes in handy when you're trying to do virtualization. And that particular machine is based on a Ryzen 5 3550H. And I really like Ryzen processors a lot for how they handle virtualized workloads. So in summary, mini PCs have come a long way in the past couple of years. We've seen them expand in terms of their memory support. We've seen them expand in terms of their CPU support. And Incus containers have come a long way in the past year, and they continue to add features. And most recently, that has been the ability to support OCI Docker containers, as well as the standard Incus containers and Incus virtual machines, which are really QEMU virtual machines. And this is video number 265 on the Scotti-BYTE channel, and my focus all along since the beginning about 3.5 years ago has been on Incus and LXD containers. And I want to thank each and every one of you who are my subscribers and invite the rest of you who are not subscribers to please subscribe to the channel. And we're going to continue to provide some really great content in the future. And that content is largely user-driven based on the questions that you ask. So I teach how to create infrastructure to self-host applications in your home lab. In other words, what do you need and how do you configure it? And when I cover a particular self-hosted app, it's really not to teach that self-hosted app per se, and I've done that several times, whether it's installing a Jitsi server or installing a discourse server. I'm really not trying to cover that particular app. I'm trying to cover a particular technique that's going to be useful in hosting other applications. And so that's why I usually cover a particular app, or I'm covering that app because I think it might be of specific interest. And so the Scotti-BYTE channel has documented and explained solutions to issues not covered anywhere else. As a matter of fact, one of the things I tell my subscribers is that I will often Google questions that I have, and if I'm completely unsuccessful after a couple of hours of Googling to find an answer to that question, I consider it to be a major topic of interest, and that's why I create a video covering that. So be sure to join the chat, which is at https://chat.scotti-byte.com, and we have quite a different variety of chat groups out there covering various areas of interest in networking, Incus, LXD, home lab issues, and even home automation. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.